Welcome to JoJo Maths. In the previous class we have seen Euclid's division lemma. Today we can see Euclid's division algorithm. By applying that Euclid's division lemma, we can study this Euclid's division algorithm. So this Euclid's division algorithm is used to find the HCF of any two given positive integers. HCF means highest common factor between any two positive integers. We can find the HCF, that is highest common factor between any two given positive integers by using this Euclid's division algorithm. We can proceed it now. How to find the HCF by using this algorithm? In the name, algorithm itself says it is a step-by-step process. Here also we have 3 steps. We are going to follow those steps one by one. First, step 1, but before proceeding to step 1, we have to take any two positive integers. So we can take any two positive integers. In general we can take, let it be C and D, be any two positive integers. With one condition, this integer C should be greater than this integer D. Okay, with one condition, this integer C should be greater than this integer D. Now we can proceed to step 1. So what is the step 1 means? We are going to apply our previous topic, that is Euclid's division lemma. Euclid's division lemma to these positive integers C and D. Okay, for that, first of all, we can recall the Euclid's division lemma statement. What the statement says, that is, if given any positive, that is Euclid's division lemma statement, given any positive integers A and B, then there exist unique integers Q and R such that A can be written as B into Q plus R, where R should be less than B and greater than or equal to 0. Okay, now take this one as equation 1. We are going to apply this lemma to our integers C and D. So we are going to substitute the integers C and D in the equation 1 in the place of A and B. So substituting C and D in equation 1. Instead of A and B, we are going to substitute C and D. Then equation 1 implies C equal to D into Q plus R, where R is less than D and it is greater than or equal to 0. So keep this as equation 2. Okay, this is the step 1 process. Only we are applying the Euclid's division lemma to our given integers C and D. Now step 1 over. Now we are going to proceed with step 2. Okay, what we are going to see in step 2 is, in step 2 we are seeing two cases. We are comparing two cases. Okay, so first of all we can see about case 1. We are going to see two cases, that is case 1 and case 2. First we can see about case 2, that is if R equal to 0. That is, if R equal to 0 in equation 2 means what happens? That is, if R equal to this integer, R becomes 0 in this equation 2 means what would happen? That only our case 1 condition. For this, we can explain this in one simple example. Now we can consider any two positive integers. Okay, we can consider any two positive integers. Now we can consider any two positive integers. Okay, let's take it as some positive integer, some 25, and another one positive integer in smallest or one digit number. We can take it as some 5. Okay, let's consider this 25 as C. We can take and denote this 5 is, D. Okay, take this 25 as C and this 5 as D. Now what we are going to do is, we are going to substitute these values, C is equal to 25 and D is equal to 5 in this equation 2. What would happen then? Substituting C is equal to 25 and D is equal to 5 in equation 2. Then means equation 2 implies 25 equal to D 5Q plus R, where this R should satisfy the condition R should be less than 5 and it should be greater than or equal to 0. Now, in order to find the values of Q and R, we have to divide this 25 with 25 by 5. So, we can divide that 25 by 5. 5 5s are 25. We get the remainder as 0. Here, 5 is the quotient and this 0 is the remainder. So, this one is the value of Q and remainder is the value of R. So, we are going to substitute these values in this. Now, keep this equation as equation number 3. Substitute the values of Q and R, that is Q equal to 5 and R equal to 0 in equation number 3. Then equation 3 implies 25 equal to 5 into 5 plus 0, where this R 0 is less than 5 only and it is equal to 0 only. So, one condition is enough. So now see here, this is the value of C and this one is D, this one is Q and this one is the R. So, we are getting here the value of R as 0, that is R is equal to 0. So, now in this case, at this stage, what is the divisor in our equation? That is, we get the divisor at this stage is equal to 5. Then this divisor D is equal to 5 becomes the HCF of our given two positive integers 25 and 5. That is the divisor. When our integer, that is our remainder, becomes 0, at this stage what we get the divisor in our equation, that is here we get D as 5. Then this 5 is the HCF of our given two positive integers 25 and 5, that is HCF of 25 comma 5 is 5. So now we conclude from this example as when we get, that is when we get that R is equal to 0 in our example, R is equal to 0 in our, when we get that R is equal to 0 in our equation, then the divisor at this stage will become the HCF of the given positive integers. So that only we are concluding from this example, that when R is equal to 0 in the equation, then the divisor at this stage becomes the HCF of the given two positive integers. So we have seen the case 1, that is if R is equal to 0, first of all step 1 we are applying the Euclid's division lemma to the given integers C and D with the condition C should be greater than D. And then in the second step we are considering two cases, that is if R is equal to 0 means what happens, then that only we are seeing in this small simple example by considering C as 25 and D as 5 with the condition C should be greater than D, that is here 25 is greater than 5. Okay, so we are taking C as 25 and D as 5. Now we are applying that Euclid's division lemma to these integers 25 and 5, and we are finding the values of Q and R. Here the remainder R becomes 0. So at this stage what the divisor is 5. So 5 becomes the HCF of the given two positive integers 25 and 5. So from this example we conclude that when R is equal to 0 in the equation, then the divisor at this stage becomes the HCF of the given two positive integers. Now we can consider case 2. Case 2 means, we know obviously if R not equal to 0 means what happens. That also we can consider one simple example. Let us take two positive integer 75 and some smallest integer some 10. Okay, here C should be always be greater than D. So here 75 is greater than 10. So consider this 75 as C and D equal to 10. Now we are going to apply same thing. We are going to apply that Euclid's division lemma to these two integers. By applying means we know that C is equal to dq plus R, where R should be less than D and greater than or equal to 0. So instead of C and D we are going to apply these two values 75 and 10. We can keep this equation as 1. Then 1 implies substituting 75 and 10 in equation 1. Then 75 equal to 10 into Q plus R, where R should be less than 10 and it should be greater than or equal to 0. Now in order to find the values of Q and R, we have to divide this 75 by 10. So 7 times, so we get the remainder as 5. So we can, this is the value of Q, we know quotient, so this is the value of Q and this is the remainder, this is the value of R. So substituting these two values of Q and R, keep this as equation 2. So substituting these two values of Q and R in equation 2, then equation 2 implies 75 equal to 10 into 7. Instead of Q we are substituting this value 7, and instead of R we are substituting 5 plus 5, where R, here R is 5. 5 is less than, here D is 10 and it should be greater than or equal to 0. Condition also satisfied. Okay, but here this is the value of C, this is the value of D, and Q is 7 and R is 5. Here we don't get, here the R value is 5 which is not equal to 0. Then means this D is not the HCF of the given two numbers 75 and 10. The divisor at this stage is not the HCF. That means we have to continue the process. We have to continue the process. That is we have to apply the Euclid's division lemma again to the numbers, again to these integers D and R, these both D and R. Okay, so we are again going to apply the Euclid's division lemma to these two integers D and R. That is, instead of C and D, here we are considering D and R. Okay, that is the step 3 process. We are going to continue, no? We are going to apply the division lemma to D and R, no? That will be proceeded as step 3 process. Then, which implies that Euclid's division lemma C is equal to dq plus R, where R should be less than D and it should be greater than or equal to 0. This is the general equation. Now what we are going to see means, instead of C we are going to substitute 10, and instead of D we are taking that as 5. That is, we are going to apply to D and R. So instead of C we are going to substitute 10, and instead of R we are going to substitute 5. That is, instead of D we are going to substitute this value 5. So C is equal to 10 and D is equal to 5. Substituting these two values in this equation, let us keep it as equation sum 1. Substituting C is equal to 10 and d is equal to 5 in equation 1, then equation 1 implies that is 10 equal to 5 into q plus r, where r should be less than 5 and should be greater than or equal to 0. So in order to find the values of q and r, we have to divide this 10 by 5. So 5 2s are 10, get the remainder as 0. So here 2 is the quotient, and obviously it becomes the value of q, and here remainder is 0, and obviously it becomes the value of r. Now substituting both of these values q and r in this equation 2 means, then equation 2 implies 10 equal to 5 into 2 plus remainder r 0. Here r value is 0. 0 is obviously less than 5 and it is equal to 0. So one condition is enough. Okay, so we get here r is equal to 0 now. Here c is 10, d is 5, q is 2 and r value is 0. So now at this stage our remainder r becomes 0 now. Then we can stop the process. So till the remainder r becomes 0, we have to continue the process. That is our step 3. Okay, so now here we get that r becomes 0. So at this stage, what is our divisor in our equation? That will be the HCF of the given numbers. So when our r becomes 0 in our calculated equation, at this stage, which one is the divisor? D value, that will become the HCF of the given two positive integers. Now here we get r is equal to 0 now. So now what is the divisor in our equation? D value 5. So here d is equal to 5. In this equation will become the HCF of the given two positive integers 75 and 10. Okay, 75 and 10. So we can write that HCF of 75 and 10 equal to 5. So from step 3 we can conclude that when we get r value, r is equal to 0 in the process, then we can stop the process and the divisor at this stage will become the HCF of the given two positive integers C and D. Hence our algorithm is proved. So we can understand the 3 steps of Euclid's division algorithm easily. Okay, so thank you. If you like this video, please subscribe to our channel.